Hey, all right. We are now going to look at fat versus narrow. We're going to really dive into what A does to a um, quadratic function and how we can use that to sort of decipher where we need to go. So, couple of little things that I always use to sort of remember this. If I see a number, I know we always see a number for A. Sometimes it's invisible number, but there's always a number for A. But what I mean by number is if I have a number that is greater than one, so higher than one, and if it was negative, then yes, we'd also say that it's like a -2 or a -3 could also apply to this. So if you have a number that is greater than one or greater than or less than -1, your graph is going to be narrower than this parent function. Um, if you see a fraction, so a number less than one and greater than -1, so it's between one and -1, you're going to see a fat graph. So let's look at this. Let's understand this. Let's sort of figure this out. I'm going to first create 3 tables for you so you can really see this sort of play out. I'm going to make these tables down here because I have the space because none of these are going to be graphed down here. So we are first going to look at our parent function, y equals x squared. If I look at this parent function, I have -2, -1, 0, 1, 2 for x values. I need to figure out what the corresponding y values are. I'm going to start nice and simple with 0. 0 squared is 0. Awesome. If I put 1 in there, 1 squared is 1. And 2 in there, 2 squared is 4. So if I were to start to graph this, I have 1, 1, and then 4. Okay, 1, 1, 4. I think I've been graphing this wrong the whole time. Whatever. Sorry. And then 1 and 4. Okay, so I can see that I'm mirroring out on these. So my first equation is just like this. All right, cool. Our next one, x, y, x, y. We're going to now look at y equals 2x squared. So I have a number greater than 1 that I'm dealing with, a number greater than 1. If this was a -2, I just know that it's opening downwards, but a number means it's narrow, okay? It's going to get skinny. Okay, so -2, -1, 0, 1, 2. 0 in there is always going to be 0. Okay, now I'm going to put 1 in there. I always start positive because it's easier. Don't make as many mistakes. So 1 squared is 1 times 2 is 2. I got to put 2 in there. 2 squared is 4 times 2 is 8. I know this is my axis of symmetry because there's no B term. Axis of symmetry is my y-axis. So that means that these should just be reflected. So I get 2 and 8. I now need to graph those. So 0, 0. 1, 2, and then 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to go way up there. Cool. I'm going to see the other bit right here. It's going to go way up there. Okay. That's narrow. Yeah, it's getting skinnier because of that 2. Last but not least, we're going to look at a fat graph. So we're going to say y equals 1/2 x squared. So same thing. We're going to look at the same numbers so we can identify or like see similarities in these. 0 in there is going to be 0. Yeah, we're all good with that. If I put a 1 in there, 1 squared is 1 times 1/2 is 1/2. Okay. If I put a 2 in there, 2 squared is 4 times 1/2 is 2. And then axis of symmetry is at 0, so these just reflect. So 0, 0, 1, 1/2, 2, 2. It is fatter. You see that? It's fatter. It's kind of cool. So 1/2, 2, 2. Okay. So if I'm looking at this as my parent function, I can use this as sort of a jumping off point for where I'm going to find my other points. But either way, I can see that a fractional, a number that was less than 1 and greater than a -1, that fractional made something fat. And this number that was greater than 1 or less than 1, or less than a -1 if we're looking at negative numbers, is narrow. So our next video is going to apply all of these concepts that we just worked on for the last 3 videos and put it to a few example problems so we can describe how they've transformed. Cool? Cool. Bye.